Hi, my name is Lily Judah. I'm a senior year public health major here at UMass.
And hi, my name is Elise Pierce. I'm a sophomore public health major at UMass, and we work in Dr. Laura Vandenberg's lab, where we use the mouse mammary gland as the primary organ to quantify the effects of endocrine disruption from environmental chemicals.
And the chemical that we wanted to evaluate for this study is called TAML, and more specifically NT7, which stands for new TAML 7. It's intended to be added to water and water treatment facilities to eliminate xenoestrogens in the water and drinking water. So what we did was we exposed mother mice in either a low, medium, or a high dose to this NT7 via drinking water. We exposed them before pregnancy, throughout pregnancy, and then throughout lactation. And then we took her pups at either postnatal day 16 or postnatal day 21, where the pups had been nursing from their exposed mother throughout their entire life up until the day that we had taken them. And then we evaluated age appropriate structures in those two groups of mice. We also had two positive control groups, ethinyl estradiol exposed mice and flutamide exposed mother mice, and then also a negative control group.
And ethinyl estradiol is a known estrogenic chemical, which is used in birth control, and flutamide is a known anti-androgen chemical, which is used to treat prostate cancer. So we were hoping that by comparing them to these two positive controls, we would also see if there are effects that look similar to those of other endocrine disrupting chemicals within the NT7 treated groups. So what we found was, after measuring for postnatal day 21, or for postnatal day 16, sorry, that's the younger age group, we measure the ductal area and the branching points of the mammary gland, because the mammary gland hasn't fully developed yet. And then the mammary gland begins developing around postnatal day 21, which is when we start to see some terminal end buds, or TEBs, which are the markers of proliferation in the mammary gland. So we measure the number of TEBs, the area of each TEB, and the ductal area and the ductal extension of the gland itself to quantify how big the gland is. And we found that for postnatal day 21, there was a significant difference between the control group and the mid-treatment level for TAML. The mid-treatment level for NT7 decreased the number of TEBs in the mouse mammary gland. And this was interesting because this means that it might be inhibiting proliferation and growth of the mammary gland at a critical age for growth to begin. And we found that for postnatal day 16, there was no statistical difference for the size of the mammary gland between any of the treatment groups. So this kind of tells us that something is happening between postnatal day 16 and 21, where potentially the proliferation is being inhibited or altered in some way by the mid-treatment group for the TAML. This has several implications, and there are several things that we can do in the future to follow up with this. The first one is to take these same measurements for the pubertal pups, which would be at postnatal day 32, and see if at puberty these trends still continue, and whether they do or don't, we will then try to figure out why we are seeing it at postnatal day 21, a difference in the TEBs. So that might be because of gene expression for proliferation, or it could be due to cellular apoptosis. So we would do different studies to figure out why that's happening in the future. We'd like to thank Joshua Mogus and Jillian Szabo, who collected the tissues and helped with statistical analysis, and also Laura Vandenberg for everything that she's done. And thank you.
Thanks.